All right, so let's go ahead and get started by graphing tangent, as well as taking a look at some word problems using trig functions today. So, um, just as a reminder, with tangent, or I should say, with all our trig functions, we used to use SOHCAHTOA, and obviously there's still reason and a time and a place to use that. Um, but we've been trying to move towards, sine is equal to y over r, cosine is x over r. And if you remember, tangent is y over x. Now, notice that when we're talking about the unit circle, and that's how we started off to begin to try to graph sine and cosine, we said that, well, because on the unit circle, radius is equal to 1, so therefore the sine value is just the y value. And similarly, I just get x for cosine, but there's no r value for a tangent. So we actually have to do some calculation, because it's y over x. There are actual values for both, and it doesn't simplify nicely to something where it's just the y or just the x. It'd be very nice if it was just the radius or something, but that would be impossible. So, because the radius is the radius. But anyway, point is, we do have to do a little bit of calculation here in order for me to actually learn, what these values are going to be. Now, so I want to look at just from negative 2 pi, which is over here, and we're going to kind of rotate our way to pi over 2. However, well, so I guess it's not technically true, but we are going to look at just this half of the circle. But I'm going to look at it as negative pi over 2 and pi over 2, since those 2 points are very similar. Then we'll take the middle point, actually, right in between that, which is going to be 0. And then we'll kind of jump to the pi over 4, negative pi over 4. So as you know, negative angles, negative pi over 2 is a clockwise rotation. We're going in the opposite direction. So from 0, instead we're going to rotate this way to get to negative pi over 2. So negative pi over 2 is the same thing as this point here, is the same point as 3 pi over 2, in terms of the value. But we remember that tangent is y over x. So all I'm going to do is I'm going to look at this point right here, 0, negative 1, and write out y over x. So in this case, it will be negative 1 over 0. And as you know, negative 1 over 0, this is undefined. A lot of students are still unsure what this actually is. If you think about it in terms of a real situation, let's say you have one of anything, a cookie, a pizza, whatever, right? One toy, and you want to give it to nobody. Well, that doesn't even, like, logically, that doesn't really make sense, right? To say you have nothing and I'm sorry, you have something to give to nobody. That logically doesn't make any sense, right? So that doesn't actually work. And similarly, let's go to pi over 2. Pi over 2, we have the point 0, 1, which again we are going to rotate, in this case, positive in a counterclockwise rotation. We have 1 over 0, and we'll get something very similar. We have an undefined value. So off the bat, we already have something that's very different than sine and cosine, because sine and cosine, for all points, there was some value, right? At no point do we get undefined. So we're going to see how that is going to affect my overall graph. Very good. Let's jump to the point right in between them, which is just at 0, no rotation whatsoever. This time I have 0 over 1. And again, kind of using the same analogy again, right? To say you have 0 cookies, you have 0 toys, you have whatever, you have nothing to give to, let's say, 5 people. Each person gets nothing, right? So this has to equal to 0. Okay. Again, it makes sense to say you have nothing, you have 0 pencils to share with 5 friends. Then each of them will get no pencils, right? So that's that's normally how I remember, right? How to differentiate between the two. Lastly, though, let's take a look at my pi over 4, which is a positive rotation, as well as negative pi over 4, which is going to be the same point as 7 pi over 4 in this case. But these are my two rotations. Okay, and I'm going to do these probably on the side here, because the calculation is not really hard, but sometimes it can be kind of confusing. I'll explain it in 2 different ways. So let's take a look at negative pi over 4 first. So what I have is my y value, which is negative root 2 over 2, divided by, big division sign here, root 2 over 2. Now, you can kind of look at this in 2 different ways, right? You can think of this as root 2 over 2. This is some number. right? This is, 1 point, or no, it's going to be less than 1, like 0.7 something, something, something. I don't know, something like that, right? And something here. So what you have really is some decimal, a negative version, divided by that same number, the positive version. So they actually cancel out to just equal to -1. You can also say, well, if I divide fractions, so I can rewrite it this way, well, that's the same thing as multiplying by the reciprocal, right? And if I write out this way, I think it's very clear that these will all cancel out. So you end up with just -1. So either way, you get -1. And if you take the pi/4 version, you're going to get the same answer except the positive. Okay, so with all that, we're now going to move into actually graphing our values. So let me go ahead and put in my undefined points, not points, I'm sorry, my asymptotes, because that's what it means. At the rotation, -pi/2 and pi/2, there is, it's undefined. You can't have a number there. You can't have any actual value. That's what it's saying. All right. And then also, I'm also going to go ahead and put in a few points here. At -pi/4, which is right in between -pi/2 and 0, I have -1. Then at 0, it is 0. And finally, at pi/4, it is +1. And so when I graph, remember that whenever I have an asymptote, what's going to happen is I'm going to kind of approach it, and it will forever try to hug that asymptote, and it's going to do the same thing on the other side. So, like I said, tangent is a funky graph compared to sine and cosine. First of all, we have asymptotes. Not only so, remember that our range for cosine and sine used to bounce between -1 and +1, but now it goes off to negative infinity as well as positive infinity. So we got some very strange looking things. Now, this is what the graph looks like if you were to graph it from -2 pi all the way to pi. Earlier, we kind of zoomed in at -pi/2 and pi/2 just to kind of get one iteration, one cycle of the tangent. But if you were to graph it over -pi/2 to, I'm sorry, -2 pi to 2 pi, this is what it will look like. And you can see there are multiple values in which you have zeros. You have a 0 here, 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 and here. So at every pi, you have a 0. You also have multiple ones, right? And this is obvious. This should be quite obvious because just like sine and cosine, tangent is it has a periodicity, meaning that it will continue to repeat certain values over and over because that's just how it works. Because it's a circle, right? You're going in a circle around and around and around. Those values are going to repeat. Okay. And finally, where it's undefined are, of course, the green lines, basically anywhere with a 2 as a denominator. Okay, so generally, I just really care that I don't really care about the second one. I just really care about the first and the last. Zeros and undefined values. I think that's I think what's important. Like I said, the asymptotes again important, and again, it is important to know that the period is only pi, right? Because if you take a look at it, one iteration is really from here to here, which is -pi/2 to pi/2. So this is a distance of pi. Now, how do you remember how to graph? And this is why I said I want you to remember the asymptotes, which is just all the pi/2s. -pi/2, -3 pi/2. It's all the negative. I'm sorry. It's all the odd pi's over 2. Okay, and in between all of your pi/2s, you're gonna have -1, 0, +1. -1, 0, +1. Right? It's getting a straight line. -1, 0, positive 1, negative 1, and then we're going to end at 0 for 2 pi. Negative 2 pi, we are going to have 0 and positive 1. But that's, I think, the general behavior, right, of tangent. I think that's easiest to remember. All right, let's move on to some word problems. Now, word problems, these are not in the packet. Unfortunately, for next year, I'm probably gonna have to supplement. So hopefully, if you're watching this in not 2021, that they are supplemented. But what I'm gonna do here is so let's just read it. We are gonna use cosine for all of these. Just an FYI. The depth of water at a beach changes every 12 hours because of the tides. So with that information already, you kind of already have an idea. If it's going to change every 12 hours, that means, well, that should be like a maximum to a minimum, minimum to a maximum. Let's keep going. This forms a periodic function. You get up early one of the days of spring break and start measuring the depth. The depth at 12 a.m. t equals to 0 is 7 feet, which is a high point. So right there, we do have some information about my maximum. My maximum is 7 feet at t is equal to 0, or in this case, 12 a.m., because they tell me this is a high point. Right? This is a high tide. Similarly, in the next sentence, they tell me the low is at 12 p.m. and it's at 1 foot. So we want to sketch a graph, so on and so forth, and write an equation. So what I want now, I generally draw very rough sketches. I just say, okay, well, I need a max, I need a min. My max is 7, my minimum is 1. And from there, I can actually kind of start figuring out my midline and my amplitude and such, because I know this is my max, this is my min, and I know that this is 6, right? 1 to 7 is a distance of 6, meaning that in between here, whatever the midline is, must be 3 and 3 away. So this, in the midline right here, this must be 4, right? 1 plus 3 is 4, 4 plus 3 is 7. So I have my midline. And again, this is a very rough sketch here, but I have a lot of information already. Excellent. Let's take a look at where my, I should have done that in a different color. That's all right. Okay, so let's take a look at the depth at 12, which is t equals 0, is 7 feet, which is a high point. Meaning, when time is equal to 0, I'm at a high point. So a max. And so, and then they tell me a low point is 12 p.m. at 1 foot. So 12 hours later, right, because 12 to 12 is 12 hours, I am at a low point. This is 12 hours after midnight. I'm at a low point. And if I want to draw one more point, I can, because I know if that's halfway, right, from a max to a min, that's halfway for cosine. And another 12 hours, meaning 24 hours after, I will have my max again. So my graph will look something like this. Not perfect, but that's okay. I just need this rough sketch, because now I can have a lot of information. I know the amplitude is 3. I know that the midline is y is equal to 4. And with this, I know my period is equal to 24. Right? So off the bat, I know some information about my amplitude. My A and C. This implies that my A value is 3. And this tells me my C value is 4. I need to do a little bit more work here. B is equal to 2 pi over the period, so 24. But not too much work. Pi over 12 is equal to B. And so if I write this equation out, y is equal to amplitude is 3. My A value is 3 cosine of pi over 12 x plus 4. That's the equation of this particular word problem. So sketching is actually the most important part here. If your sketch is incorrect, then your whole equation is going to be thrown off. Okay, and it's also really important to kind of pay attention, okay, where are we starting in the beginning? Okay, because it could be a max, it could be a min. For example, in this case, a mass is suspended from a spring is being pulled down a distance of 2 feet. Its resting position, right? The resting position, that's kind of like where my 0 is. And I'm being pulled downwards 2 feet below where it should be, right? So this tells me already that I'm going to be starting at a minimum, because the mass is released at time 0 and allowed to oscillate. So off the bat, that's the wrong kind of graph because I do need a negative 2 because I know I'm starting at negative 2 here. Now, in case you didn't know, a spring that is, I'm sorry, a mass on a spring that's been pulled down a certain amount, in this case 2 feet below, once you release it, the maximum it's going to go up will also be 2 feet. Now, in a physical sense, that should make sense. Like logically speaking, that makes sense, right? Because whatever energy that you stored into the spring by pulling down on it, when it goes up, you're not going to somehow produce more energy for it to go further than 2 feet. But it's actually the same amount of energy for it to go 2 feet exactly. All right, it says that the mass returns to the original position after 2 seconds. So after 2 seconds, it started at the bottom. It ends up at the bottom after 2 seconds. So if you want to draw a more complete graph here, that means that time equals to 1. It will go to the max. Again, not a great graph, but that's okay. Because I have the information necessary to sketch. To write an equation based on my sketch. That's right. Again, my amplitude is 2. My midline is y equals 0, and my period is 2. Again, this implies that now be careful, my a value here is actually not just 2, but negative 2, right? Because I'm starting at a minimum. So my amplitude is usually the absolute value of my a value, but that means I need to kind of go back and look at my graph and see, okay, is there a reflection or not? And then put in that negative or not. My c value is 0. I don't actually need to include that. And again, b is equal to 2 pi over the period. So in this case, b is equal to pi. So my equation then is y is equal to negative 2 cosine pi x. Don't need a plus 0. You want to write a plus 0? That's fine, but you do not have to. Again, we're looking at another water type problem. It tells me at the end of the doc is at 6 feet, the average depth. The average is going to tell me where the midline is going to be. And you can also see it, right? The midline is always kind of the average of the max and the minimum, which we've talked about in the previous video as well. This varies 3 feet in both directions. Okay, cool. So we already have a good amount of information that they told me. They told me the midline is 6, and it goes up and down. It varies, meaning it changes 3 up and 3 down. Cool. So I have my max, I have my min, and I need to figure out the rest. It says, suppose that it is high tide at midnight. If it's at midnight, meaning at 0 time, it is at a high tide. But then it goes from low to high every 6 hours, or same thing, high to low, the same amount. So at every 6 hours, it will change. So if I wanted to, I can draw a few points in here. I am not obviously required to do that. We want to sketch and write out an equation. So it's going to look something like this. Okay, not perfect, but again, that's okay. I actually don't even need this half, right? All I need is one iteration or one cycle that for the right graph. Okay, my amplitude is going to be 3, like they told me. My midline is going to be y is equal to 6. My period is going to be 12. So again, this tells me my a value is 3 because there's no reflection. My c value is 6. My b value, I do need to do some calculation. My b is equal to 2 pi over my period. So that tells me it's pi over 6. So putting it all together, y is equal to 3 cosine of pi over 6x plus 6. Awesome. All right. I think this will be the last one that we do. Yeah, that's fine. The Great Laxing Wheel, located on the Isle of Man, is the largest working water wheel in the world. The highest point of a bucket is 70 feet above the viewing platform. The lower is 2 feet below the viewing platform. The wheel makes a complete turn every 30 seconds. Sketch a graph, assuming that the bucket is at its lowest point when t equals 0. So in case y'all don't know what a water wheel is, it's just a giant wheel where there's a bucket, and they tell me it's starting at the lowest point, so I'm drawing it here, right? Okay, well that was a terrible bucket. All right, so I have some bucket here, like that, and it's gonna go around and around and around, and specifically in this case, there is a viewing platform supposedly. So there's some platform here where I guess people can stand and marvel at this amazing water wheel, right? Some walkway where people can stand on it and say, "Wow, this is so cool." Okay. Anyway, so what I would do is to say, well, let me call this y equals to 0, my walkway, right? Because it says below, 2 feet below, so that might be more helpful when I'm trying to sketch this out. 2 feet below, -2 here. At its highest point, it is 7 feet above, right? And I'm starting at the lowest point. It takes 30 seconds to make a complete turn. So meaning 15 seconds, it will be up here. Okay, so that's my graph. Again, the difference here is 72, meaning whatever the middle is, it's going, wow, that's not the middle at all. Right? Whatever the middle is, it is going to be what, 36 and 36. That's my amplitude, meaning right in the middle, I will have, what is that, 34 as my midline. So my amplitude is 36. My midline is y equals to 34. And again, my period is 30. So again, this tells me my A is 36. Actually, it's -36. I'm starting at a minimum. My C is 34. And again, my B is equal to pi over the period, 30. So pi over 15. My overall equation then is y is equal to -36 cosine of pi over 15x plus 34. Okay, I hope that helps, and that there's some clarity about tangent as well as various word problems. Feel free to come in and ask questions. Thank you very much.